Today we're going to talk about special angles that are made through a couple different scenarios, but most of them are going to involve intersecting lines, okay? So what we have here is we have two lines, and only two lines. There's only a maximum of two lines when this happens. And what happens with these two lines, there's a special thing that happens. It's called vertical angles. And what that means is that the angle that is formed from these two lines intersecting, these red angles, are actually equal to each other. So this angle would equal that angle. So whatever the measure of this would be, let's say it's 30 degrees, this one would be 30 degrees as well. And it also happens on the flip side as well. So let's say this one right here, it would be equal to that one right there. And so I know this angle would be equal to that angle. So angles across from each other are what we define as vertical angles. So you can see one is congruent to 3, and then 2 is congruent to 4. And then this would be 150 degrees. This would be 150 degrees. Okay? So what we have are when two lines intersect, the angles opposite of each other, so the ones across from each other, are going to be called vertical angles, and vertical angles are congruent to each other. All right, so with that, we're going to move on to some special types of angles. So some things are created, and most of the time with this kind of shape, you will see a 90-degree angle in this corner, or a box that's created through these angles, knowing that it's complementary. So what my class will be doing is complementary 90 degrees, supplementary 180, complementary 90 degrees, supplementary 180. Continue that mantra in your head so that you get it down, so that you know two angles when they're put together that are complementary are 90 degrees. Whether you have the picture or not, they could just say angle 7 and angle 8 are complementary. Boom. They're equal to 90 degrees when I add them together. They do not have to give you a picture. Same goes for when they are supplementary. Supplementary means that they form a straight line. Okay, two angles will form a straight line. So that the angles, when we put them together, like angle 5 and angle 6, they don't have to be equal to each other, but I do know angle 5 plus angle 6 is going to equal 180. This supplementary idea is also paired with what we call the linear pair postulate. Or linear pair theorem, sorry. It's when two angles are side by side with each other. Subtract the or and add some. I'm coming. All right. So that means the two angles, when we put them together, will form that straight line of 180 degrees. And you really want to start to commit to memory. Anytime you have a straight line, it's 180 degrees. If you can memorize that, you will make your life significantly easier. So if I know one of these is like 20, then I know the other angle has to be 160 to make them both equal to 180 when I add them together. Okay? So, complementary, 90 degrees. Supplementary, 180. Keep going with that mantra in your head, time in and time out. Please, it will make your life so much easier. Okay? And then the other thing, straight line is 180 degrees. So two angles that make a straight line are 180 degrees. So with that idea of a straight line, look at this picture. I know before I even start anything, I can draw this straight line, and I can say angle B plus angle C equals 180 degrees. I know that. Okay? Now, look at the other side. I think this is going to be the more interesting picture if you can pick up on it. I have the angle of 27 plus this box that's in the corner. And I'm just going to put box right now. And then the last one, angle A. So I know angle A. And I know all three of these, when I add them together, make a straight line. So it's equal to 180 degrees. So let's clean this up a little bit. So I have 27 plus angle A equals 180. And now we need to focus on this box that's in the corner. And anytime you see this box has a very specific meaning in any math class. This box in the corner represents 90 degrees. Okay? That's a right angle. That right angle is 90 degrees. That box in the corner, 90 degrees. So we will put 90 in there. Now, look at what we've done. We have set up a variable and we have an equal sign. We've got an equation. So combine like terms. What is 27 plus 90? Isn't that 117 plus angle A equals, keep the equals on the highlight, 180 degrees. Now, move the 117 to the other side. So I'm going to subtract 117 from both sides. That's the subtraction property of equality. And I'm going to get angle A equals, that will go to 70, 63? I think so. So that means this angle right here is 63 degrees. Which is great. But what do I do with that, Schmidt? Well, let's take a look. So we just said that angle A right here is 63 degrees. Now, if you can visualize, and this is how you have to train your brain, draw a straight line. If you can draw a straight line, then any angles that are put together in that straight line make 180 degrees. So I've got 90 plus 63 plus angle B. And that's how you want to set it up in your head. So, we know B and C equals 180. Let's get rid of that for now. We'll come back to that. Commit it to memory right now, but let's build our other one. So we have angle A plus angle B plus a box equals 180 degrees. So this box plus angle A plus angle B equals my straight line. Well, I know the box is 90. I do not know angle B, but I do know angle A now is 63 degrees. So once again, combine like terms. So I have angle B plus 153 equals 180. So we can just combine the 63 and 90, add them together because they are on the same side of the equal sign. If they're on the same side, we can combine them. Even though it's not our variable, which we're trying to solve for, it's still two like terms that are on the same side. So now we can subtract 153 from both sides, and we should get 27 for angle B. So now I know this is angle 27. But think about it. Look at this. If we would have just applied our vertical angle idea, do you see the vertical angles there? Oh man, we did all this work just to double check and prove vertical angles actually work. So angle B equals 27, we could have said that right off the bat because they are vertical angles. So if we were to write, actually let's do this. Let's Control C, Control V. Let's do this. So I have all of this right here. Let's take a look and clear all of this out. So we decided to say that angle B is equal to 27 degrees because of vertical angles. And we know angle B plus angle C equals 180. And you're going to go, well, how do I know that? Because of the linear pair theorem. So we'll say this is a linear pair. Now I can use substitution because I can plug in what my angle B is now. So I know angle B equals 27. So I can plug that in. And then let's move the 27 over to the other side. So to get rid of a positive 27, we're going to subtract it. We're going to subtract 27 from both sides. And this is our subtraction property of equality. Trying to squeeze, I apologize for that. But when you've seen this and the previous videos before, you will get used to the properties of equality because they're the same time in and time out. So we are going to subtract something from both sides. Now, one of my students will tell you the positive 27 and the negative 27 zero out. They zero out. They just create a zero. So that all I'm left with is angle C equals 153. Which is awesome. And I'm sorry if the joined over here hit everything. My bad. Oh, I don't know. I got no good places for anything. When it comes to this, I don't like trying to put everything on. All right. So, if you have questions, make sure you ask. Put it in the chat, ask in class, whatever it is. If something doesn't make sense, just break it down into straight lines. Any straight line you can draw is 180 degrees. Get used to that. That will be your saving grace. Okay? So let's look at this one. Hopefully, you can see the vertical angles right here. So before I go any farther, I can say angle B equals 30 degrees because of... I just moved it. I just moved this out of the way so it wouldn't be in the way, and it's back in the way. Oh my gosh. Okay, so angle B equals 30 because of vertical angles. Then, if we know angle B equals 30 degrees because of vertical angles, then what else do we know? Yes, angle A is congruent to angle C because of vertical angles. All right, so how does that help me? Well, so far it really doesn't, because I can't connect A and B and C and 30 together. So what else do we need to look for? Straight lines, okay? Straight lines. And I'm going to hide everything else that we don't want to focus on. So I am going to say angle A plus 30 equals 180 degrees. And why do I know that? Because they are a linear pair. They are side by side, and angle 30 plus angle A forms my straight line. Okay? Now, I can solve for angle A. So let's do that. Let's subtract 30 from both sides by using the subtraction property of equality. And that's going to leave me with angle A equals 150. And that is because we zero out the 30s. And so I know angle A is 150. Well, come back up here. I know angle A also equals angle C. So instead of A, what can I put? Oh, I could say 150 equals angle C. And you're like, wait a minute. Look, angle A equals angle C. Oops. Angle A equals angle C. Angle A also equals 150. And I talked about this in class, but I want to reiterate the importance of we're going to cut out the middleman. So I am angle C, and I want to buy an iPhone. Okay? Normally, I would go through Best Buy, and then Best Buy would go to Apple to get the iPhone. Let's cut out the middleman. We're going to go straight to the Apple store and buy the iPhone ourselves and not have to go through Best Buy. When you do that, there's a name for that. And that name, I call it the middleman property, but that's shorthand for transitive property of equality. The transitive property of equality says if A equals something and A equals something else, then those two things equal each other. So I can get that. So now I know angle A is 150 degrees. I know angle C is 150 degrees. And I knew angle B, because they're vertical angles, is 30 degrees. So I have then found all three angles that I needed. And I could prove that. The measure of two vertical angles are 58 and 3x plus 4. Find the value of x. And this must have been something else. Okay, so what do I have? I've got vertical angles. And let's label it A, B, hold on. Bad practice, bad form. Let's do this. Capital A, capital B, capital D, capital P, capital Q. I don't want anyone, we're going to do it strictly by this. Now, it said we have two vertical angles, so I know I'm going to be talking about this and that. And you could say the other two, I don't care. But it tells you one of them's 58. So I do know that it's an acute angle, so it's less than 90 degrees. So that's why I'm taking the smaller angle to make that one 58. And then it tells us the other one, 3x plus 4. So what I'm going to start with is I'm going to start with angle A, B, D. And if I highlight that, I start at A to B to D. That is going to be equal to P to B to Q. And the purist out there, mathematical purists, will tell you that they are congruent. And they're congruent by vertical angles. And then the purist will tell you that once we know they're congruent, then we can say that the measure of the angles are equal. And the purists are not wrong. They are totally okay. What I try not to do is confuse my students. It might be bad form on my part, but I feel like I'm loading them up already. I don't want to overly confuse them. But for anybody out there on the internet, properly it will be angle A, because there was no measure when I do just angle ABD. I didn't have a measure. I still don't. I haven't said anything about that 58 yet. So in my proof, all I have is this shape is congruent to that shape because I know they are vertical angles. So then we can say by definition of vertical angles, we know that the measurements are equal. So that we have vertical angles, then by the definition of vertical angles, we know that the measurements are equal. So then we're going to plug in, or even before that, we need to say that the measure of ABD equals 58. That's given. That's what the problem tells us. And the measure of angle PBQ is equal to 3x plus 4. That's given as well. The problem tells us that. If the problem doesn't tell us that, we have no idea whatsoever. So we have to it has to let us know. So the only reason we know 58 and 3x plus 4 is because it's in the problem. But now I can use substitution and plug those values in. So ABD, 58. PBQ, 3x plus 4. And now I've got substitution and solve. I tell my students that all the time. Geometry, 90% substitution and solve. All right, so get rid of the 3 and the 4. We're going to get rid of the 4 first. That is subtraction, property of equality. And that's going to give us 54 equals 3x because we zero out the 4's. And then we're going to do the division property of equality. We want to divide both sides to get rid of the 3. And that's going to go into it once. 24, so that would be an 8 and x. because we won out the 3's. We do 3 divided by 3. They're just a 1, and most math people will tell you they cancel out. I like to say they won out. So they just become a 1. All right. Now, to double check our work, we can plug it back in. We can do 3 times 18 and then add 4, and we should come out to have 58. Show that they're equal to each other. If we didn't, we might want to double check and see what we did wrong. All right, next one. Pause the video, give it a shot, see what you can do. I am not going to go as deep as I did here. I think this is beautiful, a lot of work, but let's talk about this. I have 2 vertical angles. I have x plus 3 equals 2x minus 7. They're vertical angles. So vertical angles are equal. Underline my variable and draw my line down the middle equal sign. Are they on the same side or are they on opposite sides? Because if they're on opposite sides, we have to put all the x's on one side, all the numbers on the other side. However you want to manage that. Now, I will tell you, I would not deal with negatives, so I would take the smaller coefficient, so the number in front of the variable, and move the smaller one to the other side. So I see 1 is smaller than 2, so I'm going to subtract 1x from both sides. And you might say to yourself, Schmidt, I don't know how you put that 1 in front of it. Well, I'll go back to this. What am I holding in my hand? It's a pen, and that's how we speak. It's a x, but you need to know that that x is singular. It's just 1. So we're going to subtract 1x from both sides. So that is going to be our subtraction property of equality. See, this is why I squeezed it in and was like, you'll see it plenty of times. Because you do. You see the subtraction property of equality a lot. So these will zero out. So I zero out the 1x's. And I'm left with 3 equals x minus 7. Now, I could have put a 1x there. But once again, like we speak, it's bad form. I would just leave it as an x. Now, add 7 to both sides. So we're going to do the addition property of equality. Okay? And the reason we're doing that is because we are zeroing out the 7's. So that I'm left with x equals 10. Now, this question does tell us to keep going and find the measure of each angle. Well, I have, I can throw it over here. It won't get hidden. X plus 3. And I know, and this is given, I know x equals 10, so plug that 10 in by substitution. And then I know the angle measure is 13. And, well, I don't believe you, Schmidt. Could this one be 13 as well? Because we're timesing it by 2. Well, let's take a look. 2 times 10 plus, or excuse me, minus 7. It probably wouldn't have equaled if I did a plus. Minus 7. And that's substitution. So now I have 20, take away 7, because I multiply. And that gives me 13 when I combine like terms. Combine like terms. Boom. So they're both equal 13. So I know I have the right answer without even having to go to the teacher and say, hey, is this correct? Try and do things like that for yourselves. Make your life a lot easier. All right. Pause the video. Give this a shot. See what you can do. All right. Welcome back. Make sure you change all these boxes. These are supposed to be equal signs. Something got lost in the translation. These should all be equals. So, first thing that I see is right here. And I'm even going to write angle BFA. So I'm looking at B to F to A. It's going to be equal to angle DFE. D to F to E. Those two angles are going to be equal. Why do I know that? Because they are vertical. Yes, absolutely. They're vertical angles. Okay? And the quicker you can see that, the better. But this is what I truly want to look at. Because I have angle CFD. Angle CFD, so I have this angle right here, plus angle CFB right here, plus BFA equals 180. Supplementary, linear, I hate to say linear pair because it's more than a linear pair, but the definition of a straight line, all of those tell you that this is 180 degrees. Now, CFD, that box, remember we said is 90 degrees. CFB, they tell us is 50 degrees. And let's just put an N here, because we do not know what number that is, equals 180. That's substitution. And if any of my purists want to chime in because they don't like supplementary here, let me know. What would you put? All right, now we're going to combine like terms. Anytime we have two numbers on the same side where our variable is, or even on the other side where our variable isn't, put them together. Make your life easy. So 140 plus n equals 180. Combine like terms. Then subtract that 140 from both sides. So I'm going to subtract 140 from both sides. Subtraction prop of equality. N is going to equal 40 because we zero out the 140s. And it's kind of getting hidden by my face, but you want to zero out the 140s. Good. So now I know that angle BFA, or AFB, BFA, those are the same angle, just coming from different directions. And think about the distance from home to school to work is the same as from work to school to home. So we're just traveling one way instead of the other, but it's still the same door swing. And we can say that that is 40 degrees. But once we say that that's 40 degrees, remember, go back to this. BFA equals 40. So what is the other angle that equals 40? Because of vertical angles, DFE. So this is 40 as well. And then once I know this is 40, I've got a linear pair here. This angle plus the other angle, so I know AFE is going to be 140. CFD, we already know, is 90 degrees because of that box. And boom. Dunzo. Funzo. Wrap it up, Zo. Or whatever. All right, last one. Angle PQR plus angle RQS equals 180. That's the linear pair theorem to a T. Then it tells us what PQR actually is. 9x plus 1. RQS, 8x plus 9, equals 180. That's just substitution. Well, how could I do it? Because it's given. You could write this above it and say given. You could write this above it and say given. But I really need my students to see the correlation of PQR and 9x plus 1 and RQS and 8x plus 9. So I want them to see that. So I want it to be directly right on top of each other. Okay. Now, once I have that, we're going to do a little underlining of my variables. We'll still use the highlighter though and draw a line down the middle equal sign. Now this will tell us that the highlights are on the same side, so I just want to combine like terms. Before I even do anything, I'm going to write combine like terms. So 9x plus 8x is 17x, and then if I want to do 1 plus 9, I'm going to get a 10, equals 180. So I just combine the like terms. Underline our variable again, and now we need to get rid of the 10 and the 17. We want to get rid of the 10 first, so I'm going to subtract 10 from both sides. You guessed it, subtraction property of equality. Okay. We'll be left with the 17x still. Equals still goes on the highlight, and then 180 minus 10 is 170. And we did that to zero out the 10s. Now we want to get rid of the 17. So this time I'm going to divide and use the division property of equality. So I'm going to divide both sides by 17. And we'll write that. And then 17s. What happens to the 17s? They won out. They won out. So they cancel. They won each other out. I don't want to say cancel. I hate the word cancel because it's used for too many things. They won each other out. And then 17 divided by 17 is 1, and we still have a 0. So x equals 10. Now, find the measures of the two angles, so plug it back in. So say the measure of angle PQR equals 9x plus 1. That is given. And I'm going to say the measure of angle RQS equals 8x plus 9. That's given as well. We'll move our given over a little bit to give us some space. But now plug our x value in. Our x value is 10. So keep the measure of angle PQR. Keep the 9 plus 1. Keep the measure of RQS. Keep the 8 plus the 9. But this time we're going to do substitution. We're going to plug a value in there. And that value that we're going to plug in is 10. So we're going to do 10. So 10 times 9, yep, 90 plus 1 is 91. So that's the measure of PQR. And then 8 times 10 is 80 plus 9. So that's 89 equals RQS. And you can just either put multiply, simplify, whatever you need. I would put simplify and then combine like terms. Those will be my two that I would like. For me personally, whether that's exact, the purist might slap my hand for that, but I think that's pretty good for explanations, especially if you're going this deep with everything. So I want to stop the recording so that I can make my